over to you.
All right, perfect. Good to see so many of you again. That's much appreciated. Thank you for your interest in platform engineering. So I want to, maybe not be hands-on today, but I want to give you an example how I go about designing golden paths and what they are for me. And I want to really move beyond the buzzwords. I think for too long we've been, saying words, but they didn't really have much meaning. So I promised last year that I would make the first and second quarter of this year about giving more concrete examples. We've put out the reference architectures in collaboration with McKinsey, and those are platforms packaged as code that you can test out, and they're ideal starting points to build golden paths. And what I want to do today is I want to use those paradigms, maybe look at them from different perspectives, and actually design those golden the paths together. Right, and I think also important, I want to break up a perception that there's only one golden path, and that's the scaffolding workflow at the beginning of the creation time of a workload or service. That's something that it's just not the only golden path. I wouldn't even argue it's the most important one, and it has a lot to do about not thinking about golden paths the wrong way, right? Golden paths are multidimensional. They don't start at day one and they don't end at day two. They actually continue alongside the entire life cycle of the application. So I want to start by talking about that, right? So what's wrong with day one? And then I want to look at what if every day could be day one. And this will sound cryptic, but it will sound less cryptic in 5 minutes. And then we'll just look at some paths, and then you can ask me questions, and we can, look at how can you design paths from very simple ones to ultra complex ones. Good. So I think the first thing that I want to ask is what on earth is a golden path? And my answer is it is a procedure alongside the software development lifecycle that a user can follow with minimal cognitive load. And this is an important part, it drives standardization. This sounds strange, right? And what do I mean by that? So I think it's probably best understood if you look at what's not a golden path. If you have a microservice architecture and we're zooming in now, we're looking at one specific service, and that service now requires an S3 bucket, right? Not a golden path is if you go ahead and say, okay, I need an S3 bucket. Infrastructure as code for me is important. I'm going to, use sample S3 Terraform. I'll beef it up a little bit, and I'll execute this. I have my S3, and now I have some credentials. I'll make sure they're registered in a secrets manager, and then I go into the service code and I add environment variables to the file, and then to the values YAML of the Helm chart if we're in the Kubernetes world. And then I test this, and oh yeah, it works, perfect. So I'll have that now in development. Now in staging, I'll do it again, the procedure, and then in production, I'll do it again. And yeah, that's definitely not a golden path, right? Because why is that not a golden path? Definitely not minimal cognitive load. Nothing about this is minimal. And it doesn't drive standardization, well, on many, many dimensions. You have no standardization in the way you created the S3 bucket. You have no standardization in the way you are now actually further changing config elements of that resource that might even differ between development and staging. Same holds true for the application configurations. So that means every time now a developer is deploying, the number of the level of standardization will decrease. And the uncomfortable thing with this, we have several variables now actually drifting apart. This is very quickly becoming exponential growth and complexity. And that makes it very, very hard to maintain. Now, the thing with all of these things is, for the individual user, it's a little bit painful and it's uncomfortable, but it doesn't matter that much. But if you now really compound these effects on an organization scale, and we are going into communication structures that are larger than, let's say, 50 developers, then this is compounding to be, in my opinion, one of the most, the biggest drivers of complexity, which in the end slows us down as engineering teams, which is why we're designing those golden paths. And so again, it's any procedure in the software development lifecycle that a user can follow with minimal cognitive load, and that drives standardization. For me, this could be many, many things. I am specifically always looking at things that go beyond the simple update of an image. Because, is the Git push flow also a golden path? Yes, absolutely. But that's a golden path that we've all pretty much cracked. I think the golden paths that are interesting is that if you go beyond the simple update of the service component and you change the relationship between the workload and dependent resources, and if we zoom in further, this has a lot to do with configuration management and how do we keep all of these things in chess. Now, I've hinted at this before, so that most golden paths that we're seeing developed today are focused on day one. And what I mean by that is, you're looking at the total software development lifecycle. Platform engineering teams come in and say, and the way it's going right now is unsustainable. The surface of stuff that we have to maintain increases every day. We need to somehow take control of this. Now, the answer that they come up with is to say we need to standardize the first day. So we need to actually have a templating component so that somebody who needs a Spring Boot application with some Postgres database and DNS, whatever, they have something that they can clone, GitHub templates or whatever, and then they have something, and we jumpstart this. We make it very convenient to start something. And by doing this, we're standardizing the starting point, and the common belief is that this is enough, sufficient, and then then we reach a higher degree of standardization. And the answer is, yeah, that's better than nothing. I mean, that's a low-hanging fruit, right? Everything is better than nothing. It definitely drives some standardization. There are several problems with this approach. First of all, it's pretty easy to standardize the Spring Boot application. I mean, I have a Spring Boot service, fine. But from there, assuming what the right combination of dependent resources is non-trivial, right? We're basically guessing. This is definitely not platform engineering best practices to say, well, I'm guessing what the developer will come with. It's definitely not treating your platform as a product. You're just at this point assuming, it might often be a Postgres database. It might be a Postgres database. It might be an ArangoDB. You don't know that at this point. But the problem is these, almost by definition of these static files, you can't dynamically model them. You can't say, I want this, 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 this. You can do that, right? You can dynamically model only for day one. So you could, for instance, say, well, a combination, and then we'll run some GitHub actions to combine the different files, and then we have one file, and that would be a solution to this problem. The actual problem lies in the second one, and that is if you look at the lifetime of an application, day one is only day one, right? But the application or resource, the service, might last for 1,000 days. That means in the 999 days, drift starts happening, and it will happen between environment, and it will happen between this initially templated service and its template, right? And that means we have that exponential growth in complexity. So if you're actually thinking about this like a mathematical model, you're plotting the complexity on one axis and the application lifetime on the other. What you're doing with standardizing day zero is you're taking an exponentially growing curve in complexity and you're pushing it down to standardize T0. But that means you're shifting the problem a little bit into the future, but you're not actually solving the problem. So the question is, what's solving the problem? A very long crescendo here. And my answer is always, you need to make every day zero, right? Or every day one. You need to treat every single deployment as if you would be scaffolding something. And that is only possible if we generate app and infrastructure configurations with every single release. We need to design systems that always assume they're starting from scratch. Sounds like a very trivial solution, but nobody does it yet, not many people, which is a mistake. I'm of the firm opinion this is going to be the dominating approach in some years' time, because it is so directly intuitive. If you treat every deployment as if it's the first time, it means that you can clean up every single time. It means you can change, I'm making this up, labels and annotations every single time. It means that you can say, oh, they're using horizontal pod autoscaling and staging on that many nodes, probably not a great idea. They can use that in production, but they can't in development. With the next deployment, you're automatically pulling this in. This is this idea of, we call it dynamic configuration management. Never assume something is there. Always assume it's the first day. Always create everything from scratch. And that doesn't mean, to be precise, that you have an existing database wired to a development environment and you now recreate that database. That's not true, but you act as if you would be doing this. So you're basically taking the default configs, you're letting it run, and then you say, you act as if you would be recreating the Postgres. But if the system detects that the Postgres is created, plus there are no updates, there is no diff, then nothing happens. But we're acting as if this would be the case. Good. Now, this is actually now allowing us to build those golden paths. Now, I'll get more specific technically how that works in a second. I want to give you a few examples. So let's get back to that example that I was mentioning previously. We have an OS3 bucket. We want to add that to an existing workload. You heard how long this works in this way. In this world, you need to add exactly 2 lines of code to a workload specification, and that's the trick here. Yeah, let me actually show you that first, because I think it makes it easier to follow. Yeah, so the idea of dynamically generating application is that we say the developer first describes something in abstract terms. That's absolutely necessary, because we need to have one element that is constant in this equation, and the developer describes this in a workload specification. So there are several workload specifications. I'm always using score as an example, which is selfish, but I have participated in building this. It's an open source project, and a score file looks roughly like this. You say like, hey, you have one of those score files that in every service repository, it replaces all other configurations, and it's really only one file. It doesn't differ by environment, and it also works for local. You do score compose, it will convert into Docker compose, or you do git push and it flows through your normal CI pipeline. So this, if we look at this here, says like, hey, I'm a workload name Python service. I have a resource dependency on a database of type Postgres, storage of type S3, DNS of type DNS. And what we can essentially see here is that this is an abstract description of the world. You could, send this file, just execute this file, nothing happens. And it's not saying it's that particular RDS instance. If we look at the Amazon ecosystem, but it's just saying, hey, a database of type Postgres. Now, this file, and this makes this dynamic, is actually sent through the CI pipeline with every single release. You know, normal CI, nothing could be GitLab, Jenkins, whatever you're using. And then it hits a platform orchestrator. And I don't want to make this about brand names here. You know, this could be something that you're building yourself, whatever. But an orchestration component is basically about creating those app and infrastructure configurations dynamically and then executing this. And so it's a little bit of a sort of engine room of a platform. Now, an orchestrator executes an RMCD pattern, read, match, create, deploy. It's called RMCD pattern because I'm always thinking of YMCA, and I think it's great to remember this. And so in the RMCD stands for read, match, create, deploy. In the read phase, the orchestrator is really just reading the workload specification. And remember, the orchestrator is dumb, right? The orchestrator always thinks it's day one, right? The orchestrator is our ultimate Buddhist, always living in the moment. Every day is day one. Now, then somehow the orchestrator needs to start understanding how to create the configurations, and it needs to get the context. It's getting the context usually from the deployment metadata. In this case, it could be a tag, whatever that indicates, hey, the environment type equals staging. And then it's matching this with the internal information. What are the baseline configurations that I'm supposed to use? So for instance, for environment type staging, please always use this database. Or for environment type staging, please, for whatever reason, always create a new DNS entry. And these information are stored in the baseline configurations. We're going to look at this in a second. And then in the create phase, a lot happens, but essentially it's creating application configurations, it's creating infrastructure configurations, and it's creating what we call an acyclic resource graph that is about sequencing the execution of the resources. And then that package gets executed and handed over to deploy, and unless your orchestrator has deployment capabilities. And whoops, here you go, your application is deployed. All right, long story short, now we actually can look at this a little more qualified way. Or actually, let's look at the more complex ones. I think they're more interesting. Yeah, let's take an example from the perspective of a developer, and one that is so trivial. You'll look at this and say, "Oh, I can do this in GitHub Actions," and that is true. Congratulations, you can absolutely do that in GitHub Actions, but you do not get that idea of dynamic configuration management at this point. And so what we have here is a developer wants to deploy to the development. We have our normal workload specification here, as always, and we're now actually getting the context. The context in this case, as you guessed correctly, is derived from the tag. The environment equals development. This hits the orchestrator. The orchestrator does read, create, deploy. And then we have our cluster configured, RDS, everything wired, everything injected, everybody's happy. Now, you're looking at this, again, you're saying, yeah, okay, whatever, you can do this in GitHub Actions. Correct, you can do the Git push in GitHub Actions. GitHub Actions will also probably be the CI pipeline. But the beauty here is that behind, we have that continuous standardization. Developers send something abstract, and then it can be actually synced with the default configs of the team. And that leads to a lot of things that we can do asynchronously. We can run updates, we can update our security posture, we can integrate sidecar containers, we can do all of these things up. It's a little bit like you have a bot that that cleans your kitchen every time you've cooked, and that makes it very, very convenient. Plus, it will cook it will clean this, and it will basically prepare everything for you. So then let's take another example that's more like a result of this, right? Not a feature. That is, we want to create a new environment, again, from the developer perspective for golden path, the beauty of this would be the config file stays exactly the same. It's agnostic, so it doesn't matter. The only thing that would change now is that the environment, the tag signals that the environment should be ephemeral. Here's the orchestrator. We do read, merge, create, deploy. We have, in this case, stick in the Kubernetes world, a new namespace, maybe even a new RDS there. The question is, okay, do we want this in a existing instance, new instance? Same thing for S3, DNS. And what's important to note is that we're now saying DNS, that's what's requested. The reality is way more complex. We would need a DNS, ingress controller, we would need TLS certificates. So this is something that without much cognitive load can then actually just be executed by something like the resource graph in the background. Another golden path would be you're a platform engineer, you want to update your Postgres from version 14 to 15. Now, in the world today, you would say, okay, let me write an email to all everybody. Hey, guys, please update your version 14 to 15. First week, you're nice. Second week, you're less nice. Third week, you're not nice at all. Fourth week, you go to the CTO, like, hey, can you please write the email? And this is, and then, they'll do it, and some will do it this way, and you end up with 80 different versions of Postgres. I'm often, I'm working sometimes in environments with, I don't know, 2,000-3,000 developers. You look at, okay, what are all the versions of Postgres you have? And, then it's like 250. And those aren't materially different, right? How many ways are there to configure Postgres? Maybe, materially different, not very many, but they still have that because, everybody's free floating. And that creates a crazy overhead, right? So, security has to screen this, and it's increasing the attack surface, and yada yada. So in this world, you say, okay, well, what service depends on a resource definition? Many services can share resource definitions, the exact same version of a database, and then exact same configuration version of a database, right? That's important. It's not the same database; it's the configuration version. And then we get the list of services, and then we update this resource definition, and we run a fleet update, and then we have all of the Postgres versions updated. Yeah, so this is fine. But how do we think about creating new golden paths? And in my opinion, the perfect way of creating golden paths is in a decentralized fashion. What do I mean by this? If we really want to treat our product as a platform, we can't. It's like we're a software development group, right? And we would never sit down and say, oh, let's imagine what the user wants, right? I mean, some do that, but so the better practice would be what we ask the user what they want. We do research. And the even better way, imagine you could design systems in a way where the user can signal that they need a new feature by the way they're using your product. And that's what we actually want to do in good platform engineering. So the idea here is to say, well, every time somebody hits the limit of the platform and goes off the beaten path is a big chance for us to get real feedback, to get real real ideas on how to actually enhance or expand your platform. And I'm coming to a point where I'm always saying, you should select a couple of base resources, right? But don't just build stuff. And then from there, look what people need. And so I like to take this example, ArangoDB, because ArangoDB is something that you never need until you need it. And so let's say you're a developer and you're living in this platform world, and you say, hey, I need ArangoDB. And and then the platform would respond with, I'm sorry, I don't know ArangoDB. You need to teach me. Now, what we want to reach is a state where the user can go off the path, which is why I'm always opting for golden paths over cages, right? You don't want to build platforms that say, oh, you know, you do want a RengoDB. That's great. Why don't you put a ticket into service now? And now, I'm aware that in a security-heavy environment, you're approaching production. You know, the life isn't a, yeah, in Germany we say like wish concert. But assuming you allow this from a RBAC perspective, from a role-based access control perspective, you could now say, okay, well, hey, why don't you go ahead? You add a new resource definition. A resource definition being that generic configuration on how to create an RengoDB. You add matching criteria, so we know when to use this, and you teach the orchestrator, and then next time somebody needs a RengoDB, it's already there. And I call that standardization by design. Now, this is actually, and I wanted to change this because I think it's better from a wording perspective. This is actually the platform, right? And this is actually the service level. Now, so what you're seeing here is a repository structure, because if you really think about it, platform engineering, more than anything else, is about structuring repositories, right? You know, assuming that we want to have manifestation as code and recoverability and disaster recoverability, all of this. And if you think about it, then in this world where we do opt for a certain level of abstraction and that dynamic nature, you have the service level component or service level repositories, and they contain your workload source code, their workload specification, the Docker file, depending on the way you configure this. You know, this might even also be platform owned. I'll put this into brackets. And then you have the resources that are owned by the platform or that are platform resources. You know, resource definitions, drivers, infrastructure as code, your Terraform, your Crossplane, your CloudFormation, CDK, Pulumi, you name them. Your workload profiles, I think about them as base Helm charts, for instance. Those are base application configurations, automations and compliance repositories. And now a golden path is something where this uses something that is globally configured and available here. Going off the path means actually taking some of this and expanding it. Making something a golden path is taking a new path that somebody walked and actually making it or pulling it under the umbrella of the platform and putting a service level agreement on it. Now, the beauty of this approach is that you now have you have simplicity, less cognitive load, because these workload specifications are ultra easy to use. But at the same time, you're never abstracting at the expense of context. People can still see, here are the exact configurations. I know exactly why and how this Postgres was configured. I know exactly why we're using this bucket. I know exactly how Cloudflare reacts, right? And at the same time, we have standardization by design. We're reusing wherever possible. And the platform is designed in a way where it can grow in a decentralized fashion. Yeah, and so this is what I wanted to show you today. And now I would be happy to see whether there are any questions. I can also go into other stuff in more detail if you want. Yeah, so we have one from Maria, please, you want to read them?
Yeah, thank you. The first question is, what if some apps break with Postgres v15?
Yeah, so you can think of this. You can think of this more or less like a canary blue-green situation for infrastructure, right? So if you do this fleet update, you would basically test run this, and then if there is a break, you would say, okay, this doesn't work. We are rolling back. Yeah, that would be answer. And then you would have inconsistency. One of them would be running on 14, the other on 15. But that's probably at grand scale something where then you can say, okay, let's have a human look at this.
Cool. And also Rick asked about reference architectures you mentioned. So I just for those who are just listening in, I send over the link to the chat, and we'll also include them in the follow-up.
Yeah, so yeah, so I mean, the thing about reference architectures is we are still working on open sourcing them. So all of this should be open source, the code of that platform as code thing. And we're running a little behind on the documentation, but I guess in a couple of weeks that should be done as well. If you want to play with them, you can already reach out to me, and I can probably make this happen. But we still have some licensing things that we have to go through.
Yeah. Is there any value in building a custom platform orchestrator?
I mean, this is a great question, Nimrod, but I think I'm too biased to give you an answer that anybody would believe. I think it's always worth making good build versus buy calculations. I think this is best practice if you're looking at anything in the software world. Yeah, let's leave it at this. I mean, I would always the answer honestly depends on how many resources can you throw at this, right? And if I can maybe look at a different situation. If you're Coinbase and you're paying 60 million for Datadog, does it make sense to look at building it yourself with the Elk stack? Yeah, absolutely. If you're 100 developers and you would need a good amount of full-time nannies to do that, you know, then the calculation is probably off. So the answer really depends on the circumstances and the use case.
And one last question: why not using base Docker images, Terraform, and Helm charts?
Mm-hmm. So the answer is all of them are in the mix, right? I'm all for using Terraform, and then absolutely. But that's not the thing, right? The thing is the dynamic nature. If you are able to use those technologies to get a full reconfiguration of the entire app and infrastructure layer, then you should go ahead and use those tools. So there's nothing against those tools or taking other tools, whatever. This doesn't really matter. And I'm aware it takes a little while to get into that, get into that feeling of, hey, what does that mean, recreating this with every release? It takes a while until you have that dance, but then once you see this, has a big effect.
Is there a way to monitor the efficiency of the workflow architecture described? Think Dora metrics.
Yeah. We are crazy about this, even internally at Humanitech. So we introduced that approach of dynamic configuration management in Humanitech itself 18 months ago. And we are monitoring, we're using a tool called Logilica. Yeah. And we are measuring this. We are not doing this on an individual level. We're just interested in the overall, productivity. And I'm in with those metrics. I never care about the actual metric. Like if you tell me our deployment frequency is A, I would say that congratulations, fantastic. But the thing that I really care about is the diff, right? How much better are you today than 3 months ago? That's what matters, right? The absolute number is way too much subject to your organizational context, your security posture, whatever. So I never care about that. I really care about the diff. And the core metric that I look at is deployment frequency. And we've been able to, and I've seen this in the data. We had an offsite last week, and we had a presentation by the engineering team on their productivity increase. We have seen an increase in deployment frequency 4x. Now, can you attribute all of this to this? I don't think so, because there's also, we grew the team a little bit, not that strong. And then we are also pushing for smaller, just smaller update chunks. But you can see the before-after diff, like a diff in diff analysis, and that is pretty stunning.
Cool. And the last question related to Ricardo's question, how do you collect baseline experience data to compare the new platform experience?
Yeah, and I mean, yeah, so some of the stuff that I just said, but it also has something to do with all the DORA metrics, time to market, etc. I like to also, I mean, a good question is, if you're looking at your operations team or platform team right now, are they reactive or are they proactive? You know, how many tickets do they get? How much of their day do they spend on bashing through the same thing over and over again? Can you get that down? Many people that I see coming to the world of platform engineering, I'm thinking of this bank that I worked with, going to GCP, 50 GCP projects now, creating 1,000 tickets. Mandate from the management, hey guys, please go to 500 GCP projects. And you can imagine if they now go to 10,000 tickets, you would need to linearly scale the operation team. So how can you detach actually the growth in services from the growth of the operations full-time equivalents is another interesting metric. Somebody said last year, I think it was Daniel Briand, you should measure the number of thank yous you're getting from your engineering team. That might be a little too optimistic, because the question is, do the developers care in the end? They just get used to it. But I like to look at the number of unhappiness. Like, does the relative unhappiness decrease? Like, is your NPS getting better on the product?
That's very interesting metric to measure. Can you explain how any resource, for example, Argo DB, could be added automatically into the platform reutilization?
Sure. So this is maybe where it could be interesting to get into that area of resource management quickly. Now, let me show you something. So this is Logica. This is the internal dashboard. So yeah, here, so the answer is a resource definition. A resource definition generally describes how an ArangoDB gets created, not actually generally. Now, and the resource definition do three things. They do explain the what gets created, when should it get created, and how should it get created, right? You need all of those three to do what you want to do, Ricardo. So let's go through the scenario. We have the request from the developer and the workload specification. So in this example, we have here a resource DB of type Postgres. Now, this is how such a resource definition would look like. This is a Terraform provider of a orchestrator, and so it will say a lot of stuff. Let's dissect this a little bit. First of all, it will say like what type of resource. Well, the answer is type Postgres. Then I will say like, when should I use this? And then the answer of this resource definition is like, please use me only if your app ID equals test app. This is sort of a very narrow matching criteria. It could also be like, please use me every time the environment is staging. And then you have the how, and that is, and we call them drivers. They are little services that execute something. They can just create an update. And you could have a driver that calls a Terraform file and provides an input to that file and then waits for an output. Or you could have a driver that just reaches out to the cloud API and creates a ArangoDB. Or you can have a one that creates a CRD and works with crossplane or whatever, you know, it's a combination. But this is the how do you actually create that ArangoDB? And I like to understand this with this Postgres example by looking at a question sequence. So question is, what's the requested resource type? And the answer of the system is, the resource type is Postgres. Then the question is, well, can you give me all the resource definitions that we have for type Postgres? Because you might have several ones, in your case, ArengoDB, and then it will return a list of resource definitions. So this is the what. Then it will say, well, what's the current context? And then the system will react with, hey, the context is environment type equals staging. And the question is, well, can you match the resource definitions based on that context? Can you not take all resource definition and give me the one that matches my context? Because you need to have one, like a unique identifier. And then the answer is, yes, please use a resource definition for Postgres 1. And that would be the when. So when should I use this? And then you say, okay, well, can you please take the correct resource driver and fetch me the driver URL? So the system that will then actually execute that ArengoDB, it will return the resource driver URL. And then it will say, well, can you please make a put request to the driver endpoint with a payload made from the driver input? What does that mean? Well, it means it might be Terraform might be the thing that then gives you the Postgres, but let's say you want to have a specific Postgres name. That means you want to forward the app name .something that you inject into the Terraform file to then see the execution. And then the answer is a driver output, DB name, DB user, and the combination of this actually makes the how. So this is a long answer, but a pretty precise one.
Cool. And one last question. Is there any reason not to deploy on demand?
No, there's no reason. This system should not lead to you not deploying on demand. You should deploy as often as you want, because if you are deploying and the only thing that changes is the image, everything else remains the exact same. If none of the underlying baseline configs have changed, and none of the architectural components, and you just do a git push with an updated image, which you should do as often as you wish, then this will run through. And because it is immutable, the exact same app configs will be created. The only thing that will change is the image path. And the same holds true for the infrastructure components. So the answer is you should please deploy as often as your security posture allows you, is probably the politically correct answer.
Cool. Thank you so much, Kaspar. We are on time with questions and session itself. We'll send over the webinar replay and slides tomorrow to everyone who registered. And once again, if you haven't joined Slack, please join Platform Engineering Slack. We'll see you next week. We'll talk about DORA metrics. So very interested, even came out a couple of times during this conversation as well. So thank you all and hope you have a great end of the day.
Great to talk to you. Bye.